Hello, this is Mr. Stansbury. I'm going to take you through the notes on surds and other radicals. Okay, at the end of this, you should be able to say I can simplify various radicals and surds. So let's figure out what a surd is, right? So first off, a radical is any number written with a radical sign. So for example, root 7, root 4, root -3, so forth and so on. Anything with a root, a square root sign, is a radical. A surd is a real irrational radical. For example, square root of 7, square root of 1/3, square root of 1.5. So some non-examples would be square root of 4, because the square root of 4 is actually 2, so that's not actually a surd. Square root of -3 is an imaginary number, so that's not a surd either. Square root of 1/4 simplifies down to 1/2, also not a surd. Okay? So that's the difference between radical and surd. Example 1, write as a single surd. So square root of 5 times the square root of 7 is just going to be, the roots will play together nicely, so we just multiply those roots together, so it's really square root of 5 times 7, which is a square root of 35. And we can just leave it like that because that's not a perfect square, so that is our surd there. B, square root of 15 over square root of 5 is the same thing as the square root of 15 over 5, which is the square root of 3. All right. Next example, write square root of 75 in simplest form. So square root of 75, what we can do is try to find a perfect square factor that's in 75. So really that's the same thing as 25 times 3 is 75, right? So that's really root 25 times root 3. Square root of 25 is 5, and we just have 5 root 3. Okay. When you write these, you always want to write the real number first, and then the irrational, the square root of 3, excuse me, second. Okay. Not real number, but our non-rooted number over here, our rational number, and then our irrational number. Okay? All right. Moving on. Simplify 5 root 2 plus 3 root 2. So since these have the same roots here, that's basically saying we have 5 root 2's, and we add 3 more root 2's. How many root 2's do you have? You have 8 root 2's. Okay? If you have 3 root 7 minus a root 7, that's minus 1 root 7, right? So 3 minus 1 gives us 2 root 7's. All right. Moving on here. Example 4. Simplify 3 root 8 plus 2 root 72. So again, we want to try to simplify this root 8 as much as we can. So that is going to break down into 4 and 2. Right? So that's 3 times 4, root 4 times root 2. Square root of 4 is 2. So this is going to simplify to 6 root 2. Hopefully this will also have some kind of factor of root of 2. 72 is 36 times 2. So that's really 2 times root 36 times root 2. And the square root of 36 is 6. All right, so 2 times 6 is 12 root 2, and we are adding these together. 6 root 2 and 12 root 2 is 18 root 2. Okay? All right, let's take a little short comedy break here.
Tarts box, they have directions on there. Can there be a simpler food item than Pop-Tarts? Like if the directions weren't on there, would somebody, what the? How do I get that goodness in me? What do you do? How do you get it done? You read, man. That's what you do. They have 2 sets of directions. In case you don't understand one set, you abandon that whole track and get on something a little easier for yourself. They have a set of toaster directions, which, believe it or not, is more than one step. How could there possibly be more than one step? I can only think of one. Step 1, toast the Pop-Tarts. Go ahead, toast them. Hey, are you still reading this?
Okay, let's take a look at a couple more examples here. Example 5, expand and simplify. So we have root 7 times the quantity 2 minus 3 root 7. So we're going to, just like you would with any other set of parentheses, we're going to distribute through. So root 7 times 2 is 2 root 7. Again, always the rational number first, then the irrational second. Okay, and then root 7 times negative 3 root 7 is going to be negative 3. Again, the roots and the rational numbers don't like to play together, so we just write that as 2 root 7. But these roots will play together, right? So root 7 times root 7 is going to be square root of 49. And that is going to simplify. Square root of 49 is 7, right? So 3 times 7. So this ends up being 2 root 7 minus 21. And we can't take the 2 minus the 21 because the 21 does not have the root 7. They will only subtract from each other if they both have the root 7 on the end there too. Okay. B here, we got quantity 6 minus root 2 times the quantity 3 plus 5 root 2. So this is just going to be a little FOIL problem here. Or honestly, I like to do the little stack technique instead. So I'm going to take this here, this 6 minus root 2, and put it underneath this other one. Or you can take this one and move it under there. It doesn't matter. And then now I'm just going to start multiplying just like I would a little 2-digit by 2-digit problem. So negative root 2 times 5 root 2. So 5 times negative 1 is negative 5. Root 2 times root 2 is root 4. Negative root 2 times 3 is negative 3 root 2, because the negative times the 3 is negative 3, and then you just have the root 2. Normally we put a little 0 in there to hold the place, right? 6 times 5 root 2. This is going to end up actually working out nice for us. 6 times 5 is 30. And then we have a root 2, so 30 root 2. And then 6 times 3 is 18. Now we just add up the common roots. So let's see, this negative 5 root 4 is just negative 5 root 4, which we can simplify here in a second. Negative 3 root 2 and 30 root 2 is 27 root 2. And then that gives us 18, right? Now, 5 root 4 is the same thing as 5 times 2. So that's really minus 10, right? So we have 18 plus 27 root 2 minus 10. So 18 minus 10 is 8 plus 27 root 2. Right? You could have written the 27 root 2 plus 8 also. Doesn't matter which order they go in. Okay? One last set of examples here. We have 3 minus root 5 squared. And then we have this over here. So let's take a look at this one first. So this is really 3 minus root 5 times 3 minus root 5, right? So you can FOIL that out if you want, or I'm just going to stack one on top of the other to make my life hopefully a little easier. Negative times a negative is a positive 1. Root 5 times root 5 is root 25. Negative root 5 times 3, so that's really negative 1. Negative 1 times 3 is 3. And we have a root 5 left over. All right? And then let's do this. 3 times negative 1 is negative 3, and we have another root 5. So I'm going to put that root 5 underneath this other root 5. So that is negative 3 root 5. Right? Let's see. And, oh, sorry, this is negative 1 times 3. This one is also a negative 3 root 5 from this original one. And then we have 3 times 3 is 9. And now we just add. So square root of 25, hopefully we can look at that and say, hey, that's just 5. Negative 3 root 5 and negative 3 root 5 is negative 6 root 5s. And then we have a 9 here. So 9 plus 5 is 14 minus 6 root 5 will be our final answer on that one. Okay. And then this last one. How about this? Let's FOIL this one just for those that really want to do FOIL. Okay. So 2 times 2 is 4. 2 times 5 root 3. 2 times 5 is 10. And then we have a root 3, so 10 root 3. Negative 5 times 2 is negative 10, and we have the root 3 left over. And then negative 5 times positive 5 is negative 25. Root 3 times root 3 is root 9. Okay. Nice part about this one here is that these two are opposite, so they're going to cancel each other out, and we're just left with 4 minus 25 root 9, right? Now, we know that root 9 is the same thing. Square root of 9 is 3, so that's 4 minus 25 times 3, which is 75. So that's going to give us negative 72 for our final answer. All right? Okay, so that's surds and other radicals. If you have any further questions, please feel free to ask in class. Thanks.